Yeah, question 1. The grid given below represents part of the periodic table. Study it and answer questions that follow. The letters do not represent the actual symbols. So don't at any given time try to identify. Nobody has asked you to identify. Just use them as if they were the original elements. So we have M, R, these are in group 1. We have N, P, T alongside M are in period 2. Okay, I think that is the information we have. We go to the questions. Select a letter which represents an element that loses electrons most readily and give reason for your answer. So there are 2 marks. Selecting the element is 1 mark. The reason is another mark. Now, according to us, R will lose electrons readily. The question, the way it is written, loss of electrons only occurs in majorly metals, but this side, the non-metals gain electrons. So this side lose electrons. So now we are confined to the left-hand side of the periodic table and comparing M and N. Comparing M and N, it is R that readily loses electrons. The reason is it has the largest atomic radius. Hence, the electrons on the outer energy level are loosely held. Explain why the atomic radius of P is found to be smaller than that of N. If you go to the grid here, they both belong to the same period. But since they belong to the same period, what is the trend of atomic radius across a period? It normally decreases. So the reason is, explain why. So P has more protons, hence higher nuclear charge, that pulls the outer energy level much closer. That is the reason. We now get to element M. Element M reacts with water at room temperature to produce 0.2 decimeter cubic of gas. Determine the mass of M that was reacted with water. The molar gas volume at room temperature is given to be 24. A relative atomic mass of M is 7. So the information here is mass. We have to calculate mass. The gas produced is 0.2. So we work out this as follows. We first write the equation. That is a solid reacted with water. It is at room temperature. And what you get is an hydroxide, and hydrogen gas. Balancing, we try from this side. Yes, if we place 2 here, then the hydrogens become 2 plus 2, 4. So we place 2 here to make the hydrogens 4. And oxygens become 2, so balanced. So M only this side. And then now we go to the calculations. The gas here produced is 0.2 decimeter cubic. So if at molar gas volume is 24 decimeter cubic, 1 mole of a gas occupies that volume. What about 0.2 decimeter cubic? 0.2 times 1 all over 24 is 0.00833. It's a recurring number. This is the number of moles of hydrogen gas produced. Now looking at the equation, our equation up here, 2 moles of M react to give us 1 mole of hydrogen. So the mole ratio, if you are to get, say, hydrogen ratio M, 1:2. So if you have 0.0033, then you can calculate 0.833 times 2 all over 1, and the answer is 0.016. Okay, 66 recurring moles of M. Now next is we now calculate the mass. If the mass is, if moles is equals to mass in grams all over molar mass, therefore if you know moles, you know molar mass, you can work out the mass. So mass can be worked out as moles times molar mass. Moles 0.01666 times 7. And the answer we get here is, the answer works out clearly to 0.11 rounded off to 3 significant figures. We have that as the mass. Use information in the table below to answer the questions that follow. The letters do not represent the actual elements. So we have elements, we have states at room temperature, we have the type of oxide or the nature, and then we have the bond type. We start with the first one. U, solid, it's acidic, covalent. W, solid, basic, ionic. X, liquid, neutral, covalent. And Y, gas, neutral, covalent. So identify the letter which represents the element in the table. That could be calcium, carbon, sulfur, and give a reason for each case. Beginning with the calcium. Calcium, its oxide is calcium oxide. Calcium oxide. Calcium oxide is solid. So solid, maybe we take those ones which are solid. Okay, after ticking that, we now go to the next. The nature of calcium oxide. Calcium oxide is basic. So basic, this one, not this. And the bonding is ionic. So this one. So we have W. Give a reason. The reason given here is it forms a basic oxide solid at room temperature and has ionic bond. That we know. Carbon, this one gives us two oxides. There is carbon 2 oxide, there is carbon 4 oxide. This one is acidic, this one is neutral, sorry. Yes, neutral. And then the bond type, this is covalent. So we go, okay, we have two options. If it is carbon 4 oxide, we'll follow through. It is also gas, so gas, we have only gas, neutral, so carbon 2 oxide, covalent. So the answer here is Y. Its oxide is neutral and gaseous at room temperature and pressure. Sulfur, we have two types. There is sulfur 2, sulfur 3. Both are covalent. They are both gaseous at room temperature. This is gas. So gas, no other gas. Okay, no gas. Maybe we go to the second column, acidic. Yes, we are picking on acidic, nothing else. Acidic, covalent. So the two values are consistent, acidic and covalent. At room temperature, solid, not quite. So the one that is closer to it is U, because its oxide is acidic and has covalent bonds.